Hi guys, we are on 10A Part 2 notes, and this is example number 5. So just like the problems that we have been working, this problem asks us to find cosine of theta and tan of theta, given the sine of theta is 2 over 3. And again, sometimes you need to draw your own picture. Now, just like we did in the other examples, guys, the first thing that you guys want to do is always just write your SOHCAHTOA. SOHCAHTOA is so helpful because it reminds you exactly what those trig identities are. And if it's easier for you to remember SOHCAHTOA, well, do it that way and then change it to this. Okay, and then we're going to write out, well, what is it that we're looking for? We're looking for the cosine of theta and the tan of theta, right? So we'll go ahead and write that out because we know that's what we need. So the cosine of theta, that's going to be a ratio, and the tan of theta, also a ratio. Now, what we're given is that the sine of theta is 2/3 or 2 over 3. And from our trig identity, we know that means that is the same as the opposite over the hypotenuse. And once we have written our trig identity, very easy to see that that opposite side would be 2 long, the hypotenuse would be 3 long. Now let's go ahead and draw our triangle. Now, when we draw a triangle, it's always going to be a right triangle. Trig only is about right triangles. We're going to remember to put the right angle indicator here in the corner where we have that 90-degree angle. And then, of course, we want to label. So we will look at this side diagonal from our 90-degree angle. That's always our hypotenuse. We need to place our theta. We put it here last time. Let's go ahead and put it here this time. It doesn't matter where you draw theta, but it does matter that you draw it because when you are labeling your triangle for your adjacent side and your opposite side, those sides are with respect to theta. So you need to place it. Here's theta. That means the side touching theta, of course, is our adjacent side. Adjacent actually means next to. And our opposite side is that side all the way across, not touching theta. From the sine theta that we're given, we know that our opposite side is 2 long and that our hypotenuse is 3 long. But we are not given the value for our adjacent side, so that's our x, right? We will use our a squared plus b squared equals c squared like we have. Leg squared plus leg squared equals hypotenuse squared. Of course, the c being the hypotenuse every single time. Our legs, of course, are the two sides that make up that 90-degree angle. So in this case, our legs are 2 and x. So when we fill in our formula, 2 squared plus x squared equals, now our hypotenuse is 3 long, so 3 squared. We'll go ahead and multiply out our squares here. 2 times 2, or 2 squared, is going to be 4. Then we have that x squared plus x squared equals 3 squared, which is 3 times 3, or 9. Now, of course, these are being added together. 4 is positive, so I'll subtract from both sides that 4. 4 minus 4 is 0. I don't need to write that 0, but I'll bring down this x squared. 9 minus 4 is 5. I'm not looking for that 5. That's x squared. So I want to take the square root of both sides. Square root of x squared, of course, is just x equals, oh, that's not a perfect square. You can check it with your calculator if you want. And of course, when you check it with your calculator, all you want to do is simply pull up your calculator, put whatever number you're wondering if it's a perfect square, hit your square root button. If it's a decimal, not a perfect square. We don't want to use that. We'll leave it alone. We'll just leave it as the square root of 5. 5 is prime, so we are not going to be able to reduce that at all. X is the square root of 5. So that's what we're going to put for the length of our the length of our adjacent side. That is the square root of 5. That's the value of that side length, square root of 5. Now, when we're providing our cosine of theta and tan of theta, cosine of theta is going to be the adjacent side over the hypotenuse. So our adjacent side there is the root of 5. Hypotenuse is 3. There's our cosine of theta. Okay? For tan of theta, our identity reminds us that it's the opposite side over the adjacent side. The opposite side being 2, the adjacent side being the root of 5. Now here we're okay because our radical is on top, but here we want to rationalize that denominator. We don't want an irrational number or a radical in our denominator. So remember, we're going to multiply by the root of 5 over the root of 5. That's the same thing as 1. That means we're not changing the value at all here. When we multiply this out, we'll get 2 root 5. We'll just multiply across, then multiply at the bottom. Now remember, when we have a square root squared, it just undoes this radical. So we'll get 5 on the bottom there. And guys, that's how you rationalize the denominator. I won't necessarily count this incorrect, but I do want you guys to get in the habit of rationalizing the denominator, especially if you're moving on to Math 3. All right, guys, thanks so much for watching.